Swayam Prabha. Digital India. Educated India.
We can move to the next presentation, which is the presenter is from Seattle University.
Hello.
He will be joining us virtually.
Okay. Hello everyone. My name is Zhong Si. I come from China, Xian University. The Department of Chemical Engineering. I'm very glad to stand here to report my recent works. The title of this work is Assessment assessment of methane content in nutrition containing COVID methane based on small datasets. This report is divided into 5 parts. They are background, simulation model, and their access, methodology, result and discussion, and the last conclusion. First, COVID methane is a widely distributed and clean energy. The assessment of methane content in CDM containing nutrition is important for CDM utilization, which is beneficial to production management and energy decision. However, the flow rates and the composition of CDM change with time. If the operation parameter cannot be adjusted in time, it will cause great waste of resources. However, CDM composition requires laboratory testing, which is difficult to obtain. That means if they cannot get the CDM changes correct in time, they lose the optimum operation parameters. So I built this simulation model by using design application. I choose these 7 parameters. Experiment they change CDM components. I want to change these 7 parameters to simulate they change the CDM LNG way. And then I set these 3 parameters equal and write the mirror 63 to mirror 60. Also, I fix these 2 parameters temperature equal to mirror 154. Then combined with Python code, firstly I set the seven different parameters first, and then use Python to solving these models based on these parameters, based on these conditions. So times by times, I get the dataset like this. One part is components and another part is parameters. Based on the necessity and the feasibility, I choose these 3 parameters. That is compressor, inlet pressure, compressor output pressure, valve 1 output pressure, valve 2 output pressure, and the compressor inlet flow rate, and the CDM inlet flow rate, and the heavy production temperature. So before the prediction, there is a methodology that is in the almost in all of the regression tasks, y equals function x. X is a vector like this, is a n-dim vector. As we all know, the next complexity of the system is easier to predict. So, and in this predict, there may be existing 2 ways to reduce the complexity of the system. That is, first, classifying the dataset by parameters, and the second is classifying the dataset by components of the flow rates. These two ways, we can find that these two ways is all based on serial that is put the similar data by some rules into a bag. So based on this idea, means it is classified data by parameters, and then random forest, it is classifying data by massing flow rate, and the last is multilinear perception, it is classifying data by massing flow rate. These two are classifying by the middle of the training data. And also, I choose the regressor and their random forest because it is based on second classification, and the multilinear perception because it is based on non-linear fetching. That means they in different data scale, they may have different performance. So based on this idea, based on this basic models, we can get the models like this. It is random forest only, multilinear perception only, k-means combined with multilinear perception, k-means combined with random forest combined with random forest combined with multilinear perception combined with random forest, multilinear perception combined with multilinear perception. So, in order to evaluate the 8 models we have obtained, I set up 3 schemes for the prediction performance in different difficulties. The first one has 50 training data and 20 test data. The package I choose this scheme from Python. Random forest has used auto back arrow. MLP activation is area you store is Asiam. K-means choose 2 clusters. The results of mean relative error and R square is shown as these pictures. From the picture, we can from the mean relative error, we can see that k-means combined with MLP has the least value, and from the R square picture, we can also see that k-means combined with MLP has the highest and stable values. That is to say, k-means combined with MLP has is superior than other all of the other models. Also, you can see that random forest k-means combined with random forest has the best performance in this case study. The second one has 100 training data and 20 test data. Also, I join the results in these two pictures. The results are generally unchanged from the previous ones. The k-means model is the best one, and the k-means combined with random forest and the random forest combined with random forest are worst, and the random forest only are worst. That is to say, random forest may not suitable for this classifying method because the second classification is based on data scale many, and the last one has 200 training data and 20 test data. We can find that with increase of the data, the accuracy of the random forest regression is approaching that the MLP based regression, and in this case, k-means combined with MLP is not has a clear advantage. This indicates that with the increase of the amount of data, the accuracy of the model based on classification increase relatively slowly. Then we use random forest only, or we use MLP only. The previous results are summarized in these following tables. The top table is average value of mean relative error, and the bottom of the table is value of R square. From these two tables, we can conclude that the bigger of the training data, the best performance, the prediction. And others, k-means is better than MLP only, better than MLP combined with MLP, better than random forest combined with MLP. MLP combined with random forest is better than random forest combined with random forest. This result have present this result. Okay, k-means has the best performance. In order to explore the reason for the different results, I draw the foreign teachers. Taking the first row as example, it is based on k-means splitting. The picture on the left is joined with training data, and the picture and the right one is based on the test data. The different color of the point represent different categories respectively. From these two line pictures, we can find that random forest has a better performance, has a slightly classifying performance MLP. We can from this point we can find this with this however the models with random forest has a classification showed relatively poor prediction results. Therefore, we should not classify datasets based on the predicted results. We shouldn't classify the data by massing flow rate. It will deduce. It will lead to a bad result. To figure out how k-means works, I make the following summary of different categories of the data in result of the first scheme. That is to say, the data of the training data is 15. The as shown in this table, as is shown in this table, these two, the theta 1 and this theta 2, present the state, separately present two sets of data. From the minimum and the maximum parameter, we can find that M1P, M8P, and M12P has a smaller stack among theta 1 and theta 2. That is means the k-means is, that is to say, the k-means mainly makes the classification based on these three parameters. Since these three parameters value has is very similarly, so I choose the M1P, the compressor inlet pressure as a key parameters to redesign the classifier. Based on this idea, I abandon other parameters and choose M1P only as a basis for segmentation and the reclassify. The classification criteria were the median of M1P of the training data. The prediction was still the MLP model, and the training data was selected for 50, 100, and 200. Through the classification and training, the results are shown in this picture also. It can be seen that with increase of the amount of data, the relative fluctuation of the average relative error will be smaller. It can be from the mean error. In relative error, you can see with the data set, with the data scale increase, the mean error so similarly, I calculate the mean value of the mean value ML1 and the mean relative error and the R square. Through the data comparison, it can be seen that model based on M1P have to it can be seen that the MRP has value is similarly equal to k-means combined with MLP, and the R, however, the R square is better than k-means combined with k-means. So we can conclude that finding a format classification parameter is of great benefit to improve the forecasting accuracy, and in this work, compressed inlet pressure is the very one. So we can conclude that k-means combined with MLP model has the best performance among these 8 forecasting model with small data. Comparing this models with unresolved random forest, it is deduced that random forest is not suitable for assessment of messing flow based on classification theory. Classification based on messing content is not as reliable as classification based on parameters. Finally, classification theory does work. The results of classification model of M1P shows that finding a format classification parameter is of great benefit to the improvement of forecasting accuracy. Thanks. That's all. Thanks for your listening. That's all.
Thank you.